Thank you, Madison. Hello and welcome everyone. My name's Greg Wetmore. I lead the software team at Entrust. For anyone of you who don't know Entrust, we're a global technology company. We build solutions that help our customers secure their people, devices, and data. And as part of that mission, I spend a lot of my time thinking about how to build better cryptographic infrastructure, which takes us to crypto agility. Crypto agility is not just a technical requirement, it's a critical component of modern cryptographic strategies nowadays. I firmly believe that applied at an organization-wide level, crypto agility is an imperative. It's necessary for organizations today to be able to respond to multiple driving forces, and when done well, it can deliver significant business value. Pause for the cause. This is our standard RSA disclaimer. I'll just leave it for a couple seconds for you to scan, but otherwise, we'll jump right in. So this is my traditional definition of crypto agility. It's a technical definition, it's a simple definition. It talks about crypto agility being an attribute of a system that allows it to transform from one cryptographic system to another, a configuration or policy, without impacting all the infrastructure around it. Now this is a relatively simple statement, relatively straightforward to understand, but even this simple definition hides a heck of a lot of complexity. This is really difficult to achieve. In fact, I could spend the entire 45 minutes in the session today just talking about technical approaches for how to deliver cryptographic agility into different system architectures. But that's not really the point of my discussion today. I think what I want to approach this problem is really think about cryptographic agility in a much more broad fashion. In fact, I think these straightforward, simple technical definitions are missing a huge, important piece of the scope of what cryptographic agility actually is. And we need to apply cryptographic agility at an organization level, really, to deliver the value and capability that organizations need to respond to the challenges that are in front of them. It's really not just me who have sort of gravitated initially towards fairly straightforward, simple technical definitions for cryptographic agility. I picked three what I thought were really nice, concise definitions from well-respected organizations in the field. Because they're short, I'll read them quickly. CISA says cryptographic agility, I'm gonna have to zoom a little bit, my old man eyes don't work quite as well as they used to. Designing information systems to encourage support of rapid adaptations of new cryptographic primitives and algorithms without making significant changes to a system's infrastructure. Dr. Michele Mosca at Evolution Q said, crypto agility implies the ability to quickly respond to an algorithm being broken by switching to an alternative with minimal disruption. Because PQC algorithms are relatively new, crypto agility is a key pillar of resilience in the quantum age. And finally, right from the NIST publication that was just released actually a few months ago around crypto agility, they talk about crypto agility describes the capabilities needed to replace and adapt cryptographic algorithms for protocols, applications, software, hardware, and infrastructure without interrupting the flow of a running system to achieve resiliency. There's clear themes here and definite agreement from these three bodies at least. They take a system level view. They cast these definitions in sort of the form of a technical requirement. They all share that attribute of looking for rapid capability to change cryptographic algorithms, and they all focus on or highlight the importance of resiliency. But I think all three of them are deficient in the same way I observed of my own sort of simple technical definition. Cryptographic agility is a business enabler. It's not a one-time choice. It has to be a living part of an ongoing security posture. I think we have so much room here to actually look at cryptographic agility from multiple dimensions and actually deliver more capability than these sort of feature-based views of cryptographic agility actually are. There's something intuitive, I think, about saying cryptographic agility is more than just configuration and algorithms. And that's what I'm going to look at today. That's what we're going to explore today. I want to spend some time talking about the drivers for cryptographic agility, some of the challenges organizations are facing that are pushing towards this strategy. I want to sort of break down cryptographic agility, look at it from multiple dimensions, and try and broaden our understanding of what cryptographic agility actually is. Sort of apply that organization-wide thinking to cryptographic agility. I think that lets us sort of approach a better, clearer understanding of the capabilities that organizations need to be able to deliver when they're thinking about cryptographic agility. And finally, I want to end talking a little bit about the benefits. That concept of crypto agility being a business driver is incredibly critical. I think one of the biggest challenges I hear talked about when I'm talking to my peers or my customers are, hey, how do I build awareness? How do I get support? How do I get funding? How do we make this an important element of our cybersecurity strategy? And I think part of the challenge, part of where we have fallen down a little bit as cybersecurity professionals is driving towards that clear business enablement angle for describing crypto agility. So the drivers for cryptographic agility are diverse. I'm sure every one of you probably, RSA conference talk about crypto agility is coming in here thinking, we're gonna talk about the quantum threat. And so we've sort of, all of us joined quantum in our brains when we talk about cryptographic agility. I think that's totally natural and fine. Of course, quantum computers and post-quantum cryptography, that's the new shiny object that's kind of captured all of our imaginations. But I do think it is the quantum threat and the journey to PQC that kind of tips crypto agility from, hey, this is really important and good to have, towards imperative. But I think there's some pretty strong drivers for crypto agility that have nothing to do with the quantum threat, that have been around for a while. So we're going to look at all of those things. I chose 4 sort of big, hairy problems that organizations face today as they're thinking about adapting their cryptographic infrastructure. And so let's sort of look at that. Of course, we're going to talk a little bit about the journey to quantum safe. Of course, almost every system that performs some security function in your organization is going to have to be updated. The cryptography in it is going to have to be updated over the next few years. We've got an incredible sprawl of devices and data, and that's causing an explosion in the number of cryptographic assets you all have to manage. Operational and organizational complexity. Frankly, we're not actually very good at managing this stuff. So we're going to look at that a little bit, and then finally I'm going to talk to you a little bit about short lifetime certificates. Did I hear someone say 47 days? Yeah, So yeah, let's start with the quantum threat. I don't want anyone squirming going, why isn't he talking about quantum? So we'll start right there. Again, I'm sure the professionals in the room here are pretty comfortable with this concept. We're of course concerned about the ongoing development of quantum computers. Eventually we're going to get to what we call a cryptographically relevant quantum computer, and that's a quantum computer large enough to threaten the security of the integrity and confidentiality of the world's data. And of course, there's incredible investment in the quantum computing space. I read somewhere where global investment has surpassed $55 billion invested in quantum computing. And it's the world's biggest governments, it's the world's biggest tech companies, and they're extremely motivated to make progress. And if you follow the space, there's exciting announcements all the time. Even over the last few months, there was a pretty cool announcement from Google about their Willow crypto chip, and there was another one from Microsoft about their Majorana 1 crypto chip. And we've reached the point where experts agree it's a matter of when this happens, not if this happens. And of course, there's some pretty urgent threats that we're concerned about right now. You've probably heard of Harvest Now, Decrypt Later. We've got sophisticated adversaries. Most of the world's biggest governments have active programs where they're scooping up information, traveling over the internet. Your valuable long life data, it's encrypted, but it's subject to being sucked up as it's moving across WAN links and internet links. And of course, one of the reasons organizations are doing that is they believe that in the coming years, they'll be able to decrypt that information. And if it has value 5 years from now, 10 years from now, of course, that's a breach. The other concern we've got is connected devices. Of course, many of those devices have in-service lifetimes that are going to last longer than 5 to 10 years. And at that point, potentially the security mechanisms built into those devices, the firmware integrity, the roots of trust, the identity, those are potentially subject to attack from quantum computers. When I look at this timeline, it's a call to action, and it's a little bit scary. It was last month, 6 or 8 weeks ago, maybe a little longer, NIST released sort of their first clear guidance on dates where they're sunsetting and deprecating traditional public key cryptographic systems. So 2030 stands out there. NIST's talking about, for at least federal organizations, deprecating the use of traditional public key cryptography in 2030 and fully disallowing it by 2035. I've got customers looking at that 2030 date and starting to sweat. Like when you start thinking about it's going to take me 2 or 3 years to roll PQC into my production systems. It's going to take me a year to plan and test. And then there's the time it takes me to come up to speed and go through procurement, all the other things that organizations have to deal with. You quickly come to a realization that we're behind. 2030 is just around the corner. By the way, we're 12 years into the transition between SHA-1 and SHA-2, and organizations still have legacy deprecated crypto in their environments. So clear call to action here, clear and present, urgent action required. That device and data sprawl. Every time I watch or listen to a crypto presentation and the slide with macro statistics pops up, my eyes just glaze over. So I'll forgive you if that's how you treat these, but maybe indulge me. This is my one and only macro statistics slide. 75 billion connected devices. That's 10 for every single person in the world. 175 zettabytes. A zettabyte is 1 billion terabytes. That's like every person in the world carrying around 20 workstation-grade laptops filled with data. This is incredible scale. And when you apply that scale to cybersecurity best practices, think about NIST CSF or Zero Trust. Those best practice frameworks call for protecting every one of those devices and encrypting all of that data. And of course, that is causing an incredible explosion in the number and the variety of cryptographic assets that you have to manage to protect all of this. Your keys, your certificates, your secrets, your cryptographic libraries. And oh, by the way, AI is having an interesting dynamic here. In the world of AI, we're building these massive centralized data sets that are used for training all over the place. And yet one more challenge data security professionals have to manage in their environments as they're thinking about building these huge centralized stores of data. And guess what? We're seeing more and more breaches caused by poor key management practices. There's a couple of examples up there, whether it's a critical key that's lost as part of a breach or compromised, or just a careless mistake where production secrets or keys are leaked when some source code gets published to a public Git repo. There is real consequences to poor key management here. And all of the scale of this isn't helping you solve that problem for sure. Operational complexity. Evidence shows it. We are not very good at managing this stuff. Outages caused by certificate expiry, that still happens again and again and again. Like we've been on that one for a decade. Tough problem. Keys exist all over organizations today where there's no documentation that exists on who owns these keys, what's this key used for. There's no clear policy or ownership. There's no lifecycle definition for how is this key created, where is it used, when does it get rotated, when does it need to be deleted or destroyed. And frankly, visibility, discovery, inventory. I've got customers telling me this is an impossible problem. Like this is difficult. So we are not doing very well operating and managing this stuff today. We really have to continue to build maturity or else we're in trouble. Short lifetime certificates. The world of at least publicly trusted certificates is changing pretty quickly. I hope you all saw it go by. It was just a couple weeks ago, the CA Browser Forum passed a new ballot that's dramatically changing the lifetimes of publicly trusted certificates. So those are those certificates you're putting on your web servers and other places in your network where you need public trust. Of course, we're at 390 days of validity now. As of March of next year, we're going down to 200. March of the following year, so 2027, 100 days. And March of 2029, 47 days. And so perhaps you're thinking, especially with this one, hey, you're straying a little far away from crypto agility. What does this have to do with algorithms? Just bear with me. I'm going to make the case that I think cryptographic agility really needs to be defined much more broadly. Cryptographic agility capabilities you need to be able to discover, have visibility into your cryptographic assets. You need to be able to control them with policy. You need to be able to automate the lifecycle management of those cryptographic assets. And this is a great example. It's an acute example of a problem that only automation fixes. So I think it's incredibly relevant to the discussion about cryptographic agility. So, we've got all these driving forces. A lot of them aren't new. I kind of asked myself the question, how did we get here? Why have we gotten away with this for so long without having more mature capabilities to manage our cryptography in our organizations? And why now is it time for change? I come back around, I think, to the quantum threat at this point. I think the quantum threat pushes us to that tipping point. It is that change that's coming that, in my mind, means status quo isn't enough, isn't good enough, isn't going to be good enough, and will push us over that threshold for change. The reason we've gotten here, the reason why we don't have some of these capabilities in our organizations is really because we've spent the last 30 years in a very static time for crypto. RSA has been widely used for more than 30 years, elliptic curve for more than 20 years. We've done small cryptographic changes. We've deprecated MD5. We've done SHA-1 to SHA-2. We've done triple DES to AES, but those are fairly small. We've never faced this sort of discontinuity that the quantum threat represents. And I don't think it's an astounding thought. My prediction is the next 10 years of crypto is going to be way more dynamic than the past 30. NIST just announced a few weeks ago a 5th quantum safe algorithm that they're going to take through the standardization process, HQC. The NIST post-quantum competition is still going. They're looking for more algorithms, primarily focused on ones that have positive capabilities to help embedded systems and constrained devices. So we can't really use the past as our pattern here. We've got to plan for change. And again, here's where I think crypto agility is the sort of the secret to making this work. So I kind of want to come back to where we started and start talking about what cryptographic agility really means. I think understanding the different dimensions of cryptographic agility is essential to coming to that sort of more fulsome definition of what cryptographic agility means and how we can deliver capabilities organization-wide that will help solve some of these key drivers that I just talked through. And these dimensions aren't only technology. So I want to look at this from sort of that people process technology, three-way analysis method. Of course, people process and technology is a fairly common way to look at cybersecurity challenges. And I think it's very instructive to look at crypto agility this way. I think it really does help us get to that organization-wide view and definition of what cryptographic agility is. So let's start with people. Cryptographic agility really starts with human capability and awareness. The best technology fails without informed and engaged teams. So some of the key elements and features of this dimension of cryptographic agility, for me it all starts with accountability. Someone, some group in your organization has to be responsible for defining the cryptographic practices and processes that your organization is going to follow. Do you have people in your organization with crypto agility or crypto management in their job descriptions? Great question to start. Then I come back to training and awareness. Your technical teams, your IT teams, your dev teams, your operations teams, they need to understand and be aware of cryptographic best practices and threats and risks related to cryptography. Your legal compliance, your business stakeholders have to collaborate together and understand what data protection, regulation, and regimes either constrain their business or hopefully enable their business. And finally, executives. Your executive leadership needs to understand and balance risk across the entire organization, but especially they need to be sponsors and stakeholders, budget for, prioritize investment to develop cryptographic agility in their organizations. So when I look at this sort of stack of stakeholders, those narrow feature-based definitions for cryptographic agility kind of fit right at the bottom of this chart, in the box 1 and box 2. These are the groups of stakeholders who really are working with the technology at the level of security protocols or software architectures. They're thinking about features like, how do I build configurability into the cryptographic primitives that are being used by a given application? Can I externalize cryptographic services? Can I abstract cryptographic services in a way that provides more agility? And so that feature-based view of cryptographic agility really is nice and fits right there in the bottom of this chart. And as you start to go up the stakeholder stack here, I think you start to identify different value attributes for cryptographic agility that need to be applied or need to deliver value to different stakeholders. Your IT and your operations team, they own the infrastructure. They are responsible for SLAs. They're usually the ones that own the cryptographic objects that protect all the data and identities that are in your production systems. So value attributes like interoperability, ease of integration, scalability, resilience. Those are some of the attributes for cryptographic agility need to be delivered to those stakeholders. As we get up to the next level then, your InfoSec teams, we need to deliver value out of crypto agility for those personas. So they're the risk managers. They need to be able to measure compliance and risk and identify issues and have the ability to initiate remediation. And finally, as we get to that executive level or C-level, ultimately crypto agility needs to provide value right up to the top of an organization. Executive and boards own the growth strategy for organizations. They need product teams to be able to deliver new capabilities securely and compliant and quickly. And they need to balance and understand the risk across their organization. And again, here's a place where crypto agility can provide value attributes. Switching gears a little bit, processes provide the structure needed to manage cryptographic change systematically and repeatedly. Processes, to me, are the backbone of effective crypto agility. They inform how governance, compliance, risk management practices influence an organization's ability to adapt to changing cryptographic needs. So here are some of the key elements in the sort of process space as we're breaking down cryptographic agility. Policy management and governance. You have documented policies and practices for managing your cryptographic assets. Risk and compliance integration. Do you understand how your cryptographic standards are aligned with regulatory frameworks? PCI, HIPAA, GDPR, California data privacy, NIST. There's all kinds of regulations that are very prescriptive about data protection and handling of cryptographic keys. Can you measure your adherence to those standards if they're relevant to your business? Do you have a program that manages vendor and ingredient technology that you're bringing into your organization? Are you asking for things like a listing of ingredient cryptographic mechanisms? Are you looking for support for algorithm agility? Are you asking about PQ, the capability to support a migration to post-quantum? Change management and incident response. Are you planning for change safely? Are you thinking about cryptographic failure and how you're going to handle cryptographic failure? And finally, traceability and audit. Are decisions clear and documented and reviewed? Do you have the ability to audit compliance going forward? So these are the elements of process that we need to deliver capabilities out of our cryptographic agility program. Here's a few reflection questions I think that perhaps help identify gap areas or areas of improvement across your organization. I'll read a few of them just because it's a bit of an eye chart. It's even an eye chart on my speaker podium here. How do you know if you're compliant with corporate security and data protection policies? Where are your keys being stored? Are you following industry best practices when managing keys and secrets? Who created this key? Who has the permission to access this key? How do you know these keys can't be exported to another country and violate your data sovereignty mandates? What data or workload is this key protecting? Do we have critical high-value keys in my organization that aren't being protected in hardware? Do I have granular documentation and an accurate audit trail of how keys are being used and secrets? What type of security strength is required for a given key? Why is this key being used in production when it was created for test infrastructure? And finally, when do my keys need to be rotated, retired, deleted? Lots of good questions that perhaps identify gap areas in process. Switching gears to sort of our third dimension again. So technology is obviously the foundation that enables or perhaps inhibits cryptographic agility through your system design and your tooling. I find these three pillars of technology instructive to really broaden the the way we think about crypto agility and the capabilities we need to deliver out of the technology infrastructure. Find, control, and automate. Those are my three key capabilities. You can't fix a problem you can't see. Your infrastructure has to provide you the ability to generate that inventory of your cryptographic assets. Keys, certificates, secrets, crypto implementations across your whole organization. Control. You need to be able to control those assets with policy. More than that, you need to be able to measure, report on compliance, and identify risk areas. And finally, you need to be able to initiate remedial action out of your control pillar. And finally, automate. We talked about those short lifetime certificates, but really at the scale that we talked about, 175 zettabytes and 75 billion connected devices. I know every organization isn't quite that big, but safe to say that the only way to handle these kinds of problems is with automation. Find, control, and automate. I really like this diagram. And I'm stealing a concept that comes from the world of networking. You've probably been exposed to control plane versus data plane. We're starting to use that way to analyze systems, even beyond just networking, cloud, and other things. So in networking, the control plane is really the part of your networking equipment that is responsible for defining how data should move, the routing policies, and monitoring system performance. The data plane in a networking environment is responsible for actually moving the bits into the right places, acting on the configuration done at the control plane. I think this is an extremely useful way to think about the technology and capabilities we need to deliver out of a cryptographic agility program. The control plane here is responsible for defining how cryptography is used across an organization, how it's enforced, and monitoring the performance, being able to inventory those cryptographic assets and measure compliance. The data plane here is the actual infrastructure that's doing the cryptographic operations. It's the thing that hands a key off to your database system to do TDE, or as part of your CI/CD pipeline, puts a key and a certificate into a web service, or applies that digital signature on a legal document. That's the data plane in the world of cryptographic agility. So I'm going to pop down and sort of look at each of them in a little bit more detail. We'll start at the bottom. So the technical layer, or the data plane, this is where your actual cryptographic capability in your organization sits. It's technologies that you likely have in place today. PKI, HSM, key management systems, secret management systems, certificate lifecycle management. It's where the rubber hits the road. It's the actual keys and cryptographic material and secrets and certificates. Agile cryptographic infrastructure here in the data plane needs to provide standards-based interfaces. They're easy to integrate with, modern scalable architectures that fit demanding system needs. This is the set of capabilities you need to have in place to protect your identities, devices, and data. Popping back up to the top, now you're thinking about the control plane. Actually, I'm going to go back. I want to talk here about, what persona are you targeting with capabilities here? Because I think that's really relevant. There's actually, I think, of two different personas operating in these two different layers. Your data plane really is targeting your IT operator, your DevSecOps person, the person who's actually fingers on keyboards, building systems or managing systems that are supporting the infrastructure and applications that run your business. So their needs out of an agile cryptographic infrastructure are different. And we talked about some of those needs. As we pop up to the management layer or the control plane, you're targeting a different individual in my mind here, a different persona. This is that InfoSec or risk manager persona who cares about different things. Here we want to be able to provide capabilities to that persona to be able to define cryptographic policies, to be able to ingest or discover inventory cryptographic assets, evaluate risk, report on risk, measure compliance, and ultimately identify areas that need remediation. So as we sort of wrap the multi-dimensional breakdown of cryptographic agility, I thought this was a nice spot to throw this concept out there and perhaps something new for some of you. I think it's really useful as organizations start on a program like crypto agility to be able to have some form of tool that allows you to measure your current state and give you a sort of step-by-step model for positive progress. I actually came across this cryptographic agility maturity model. Wow, mouthful. CAMM, C-A-M-M. This was developed by a group of German academic researchers out of the University in Darmstadt, Germany. And this actually was referenced in the NIST cryptographic agility white paper. So it's starting to build a little bit of a following. It's probably beyond the time we've got today to really dive deeply into this, but this cryptographic agility model defines 5 sort of maturity levels and actually goes into fairly good detail about sets of requirements that fit each of those five maturity levels. Really easy to find on the internet because there's not a heck of a lot of these out there. Just a quick search for cryptographic agility maturity model is going to pop you up into this. You know, I would say when I looked at it, it's not perhaps quite as mature as some of the other maturity models that are out there that are targeted at different cybersecurity practices and frameworks, but I think it's a really useful first step. The other measurement tool I encountered just recently, it was actually after I had to submit my slides, so I don't have a visual here for you, but it was presented as part of the NIST Cryptographic Agility Workshop. It was just a couple of weeks ago. One of the organizations presented there talked about defining a cryptographic agility scorecard as a measurement tool. And what they basically did was define a number of KPIs, or key performance indicators, and they took an approach kind of similar to what I did, broke down the different dimensions of crypto agility. Their KPIs fit into those people, process, and technology divisions. And then they scored each of those KPIs, like a 1 to 10 maturity score. And that scorecard, I think, gave them a sort of map to where they had better capability versus sort of hotspots where capability really was low. And it also, they talked about this scorecard giving them the ability to sort of measure over time progress. So I think there's some useful tools out there that, as you're thinking about your program and the things you're trying to accomplish as an organization, that perhaps help you communicate sort of the plan and measure progress along the way. All right, so I want to sort of come to the third part of my presentation today and talk more about the business value. I think we've gotten this more fulsome, broader understanding of cryptographic agility. Like, it's not just algorithms and configuration. It's not that crypto agility isn't a feature. It isn't a technical requirement. I mean, it is, but it's so much more than that. Crypto agility, when done right, just isn't about security. It's about resilience and efficiency and business flexibility. I had a great chat with a gentleman yesterday, actually, and just perfect topical. I'm going to throw this into my presentation, I told him. He said, crypto agility is a business problem hiding behind a technical problem. And I think that's a sort of insightful way to think about it. Everyone, oftentimes the people thinking about crypto agility are individual contributors or workhorses in an InfoSec or IT or development organization. And I think that we have a real challenge to turn crypto agility into that business problem that's hiding behind that technical problem. I think in order to make progress here, we need to do a better job. We, all of us, need to do a better job at describing the business value, reducing risk, avoiding disruption, driving operational efficiency, delivering compliance, enabling scalable innovation. These are all parts of the business value that cryptographic agility can provide. So I'm going to take a couple minutes and sort of examine a few of those areas. This is a slide I use a heck of a lot when I'm talking to my customers about the journey to quantum safe. And it really kind of encapsulates that entire cryptographic agility breakdown that we just talked about: people, process, and technology, and find, control, and automate. And so in my mind, crypto agility is the secret sauce here. It is the capability organizations need to develop to make this transition to quantum safe an orderly, orchestrated one, and not a chaotic fire drill. I talk my customers through the slide and basically say, hey, start with accountability, people. Find out who in your organization, or delegate in your organization responsibility. Start with prioritization. Think about in your organization where you've got that critical long-lived information. And then we really focus on some of those technical capabilities on crypto agility. You don't need new PQ standards. You don't need interop. You don't need protocols from the IETF to build cryptographic agility into your infrastructure. find your cryptographic assets, control them with policy, automate the lifecycle management of those assets. And that's kind of the center of this journey slide. And finally, I think about the end of the slide as my data plane for my cryptographic infrastructure. Am I deploying the capabilities with modern cryptographic infrastructure that allows me to deploy PQ cryptography, certificates and keys when the time comes, when I'm ready, when the surrounding infrastructure supports all of this stuff? Do I have the data plane underneath me that allows me to make this transition? So, reduce risk, drive compliance. The post-quantum journey fits into that. I really like this one. This one is one that I think even is not fully developed in my own mind. And it fits into that category of generating operational efficiency and enabling scalable innovation. Guardrails let you go faster. Guardrails let you avoid disaster. Think about this. Easy integration points and centralized cryptographic services allow product teams to deliver secure, compliant, innovative solutions faster. They don't need to reinvent the wheel. They don't need to be deeply experts on cryptography. Crypto agility is a force for reducing costs and driving innovation. How do we make that real? Because to me, there's a secret here that unlocks support for cryptographic agility programs, funding, those kinds of things. When you can speak in the context of driving operational efficiency and enabling innovation, these are things that C-level, board-level stakeholders care for. And finally, I am sure that if you haven't already, the professionals in this room are probably going to get the question from their boss or their VP or their C-level, hey, what are we doing about quantum? And a comprehensive capability to manage your cryptographic assets really is the only answer to demonstrate that readiness. I'm going to come all the way back to where I started. I firmly believe that cryptographic agility applied at an organization-wide level is an imperative. It's necessary to respond to multiple driving forces, and when done well, it can deliver significant business value. So I'm going to wrap up. I'm going to leave you with a few takeaways. I suspect most of the programs that you're going to sit through at RSA have this apply takeaway slide. And really think about that people, processes, and technology breakdown that I presented. Where do you want to start when you go back to your organization? Is it in the people part, in the accountability part? Where do you start? Is it in sort of the middle of that journey slide of taking the first steps towards building a more mature capability to manage your cryptographic assets? Building that cryptographic inventory and discovery of keys and certificates and secrets. Or are you a little further along? Do you have some ideas on getting ahead on some of that core capability in that control plane or data plane concept that you want to add to your technology infrastructure? And some of those maturity assessment tools and measurement tools, are those useful for you to take away and help you communicate with the stakeholders in your organization about what you're trying to accomplish, where you are today and where you're trying to go? And finally, I hope there's a few of you in here who are ready to say, hey, I want to put PQ certificates or keys into my labs, or maybe in 2025 into production as we start to get broader support across the vendor ecosystem for post-quantum. So my last slide, there's some really good information out there. I encourage you, if this is a topic you're interested in, I just picked a couple that I thought were particularly good, but I suspect you'll find more. The two sort of really good technical documents I used as I'm trying to understand the different dimensions of cryptographic agility. One was from FS-ISAC, which is a financial services organization of sort of group of information security professionals that support the financial services industry. They wrote a really nice paper. I thought the NIST paper that came out a few months ago also is really good. Sort of takes a lot of different angles to talking about cryptographic agility. And finally, there's some good information out there from vendors too. I put ours, of course, up there, but my peers at the show here have a number of them have some interesting and insightful things to say about cryptographic agility. So, want to thank you all very much for joining me this afternoon, or this morning still, I guess. Love to invite anyone who's got one to ask questions or make comments. We've got a few more minutes. I believe. I think there are mics in the room. Hopefully they're working and we can hear you.
Can you hear me? Of course.
Yeah, perfect.
Greg, excellent presentation. I'm a researcher as well. I've been 5 months into my PQC CLM research, and I'm really happy that your research aligns with a lot of what I found. Just a commentary, I work with hundreds of CISOs worldwide, and as I've done the research and partnered with Sectigo, AppViewX, Keyfactor, I found that the very base level understanding of how to achieve that crypto agility is to get the observability in place and scoping the type of certificates, and really understanding the life cycle of enrollment, renewal, and revocation. That's just kind of a huge gap, right? So once you get that piece in, you build your inventory, understand the protocols, ACME, SCAP, CMP, I feel that people will be more successful. That's such a big gap. Jump into PQC without having the table stakes like CLM, right, and scoping.
Yep.
Anyways, thank you. This is great.
No, I agree with what you said. I think the refinements I would add is, CLM is a pretty mature space, and I think many organizations have some form of CLM, whether it's homegrown, whether it's commercial solutions from Entrust or some of the providers that you talked about. But I think those technologies are often really only looking at certificates. And there's a lot of gaps around, in my mind at least, keys, certificates, secrets, cryptographic implementations or cryptographic libraries. In the context of the journey to quantum safe, you really need that visibility across the entire estate of your cryptographic assets. And sometimes certificates, you have more capability than some of those other spots.
So real quick, you didn't really touch on this, but could you talk about full versus hybrid crypto, transition just for a second? Because NIST kind of says go full, and practically hybrid's probably more realistic for people. So what are your thoughts on that?
Yeah, so I think of, so first of all, for anyone who doesn't know, a hybrid cryptographic system is a system where you're using both traditional public key cryptography with a quantum safe public key cryptography. And so there are different ways to, or different mechanisms that are hybrid. If you actually have tuned in and saw Google talk about, hey, we enabled PQ in our data center, or Cloudflare said, hey, we turned on PQ in our CDN. What they're actually turning on is a new TLS 1.3 hybrid key exchange algorithm suite. And that's going right after that, protecting the encryption key that you're negotiating as part of a TLS handshake from the harvest now decrypt later problem. And that's probably going to be the first widest deployed PQ use case on the internet. You just need servers and clients that are updated to the new TLS 1.3 specs, and they can do hybrid key exchange. So you're actually negotiating that key with a key exchange that's using traditional public key cryptography and PQ. And there's some interesting hybrid certificate formats. There's another mechanism for hybrid where certificates potentially can contain more than one key. And there's a number of different reasons for hybrid. There's a security argument to make, at least in this period where we don't have a cryptographically relevant quantum computer. If you're doing both, you're guaranteeing that you never fall below the security level of the traditional cryptographic system. So some organizations and jurisdictions, I would say there's a lot stronger direction coming from Europe. I saw just Israel actually talked about this recently, sort of pushing their spheres of influence towards hybrids for that reason, the security promise that a hybrid makes. I think there are other hybrid formats that are potentially useful for backwards compatibility. There's a couple of different hybrid security formats that put the traditional key in the normal spot in the certificate and the post-quantum key in an extension. And a format like that lets a legacy client use the PQ key, or sorry, the legacy RSA key, for instance, where it expects to find it, and an updated client potentially look for a PQ key in a different spot. I think what I'm seeing is, so first of all, the IETF, the only hybrid format for certificates the IETF is going to adopt is composite. And so that's a format that, that goes after that security rationale for hybrids. It actually blends the two keys together in a cryptographically secure way. I still think, though, of hybrids as more of a specialized requirement. So my advice, at least when it comes to PKI for my customers, is, hey, you're going to need your legacy PKI for 5 to 10 more years at least. We just know it's going to take that long to get legacy crypto out of your environment. you're going to need to stand up a PQ, pure PQ PKI in your infrastructure 2025, 2026. Because we're going to start to see demand and support for pure PQ certificates. So every organizations need both of those. Hybrid certificates, hybrid PKI, I think is more of a specialized niche use case at this point. It's hard without a crystal ball to know, are there jurisdictions in the world that mandate it? Are there protocols or use cases where hybrid's really important and is part of the standard? Or are there threats that your organization, or risks that your organization want to manage where hybrid is useful to you? So to me, it's just a sort of a feature checkbox of your data plane. Does your cryptographic infrastructure support hybrid? So when you need it, if you need it, you've got that capability.
Maybe a more tactical question. Public companies, private equity companies, they're on a deadline and they have tight budgets. What is the, I guess, the argument for looking into PQC now and trying to size, the investment in the long term? Are there tools available to do that, or based on your experience, what's the argument that gets somebody excited about the sense of urgency to do this now?
Great question. It's one of those challenge areas that I think we're all struggling with right now. And we're sort of inching towards, in my mind at least, a better, broader understanding of the quantum threat and the strategic imperative towards planning for this journey to PQ. So I definitely have some of my customers, some of the folks I talk to, who are there, who have support at the executive levels or the board levels for this being part of their cybersecurity program. And they've allocated budget and they're working on a program. I think the majority still, though, are in that building support mode that you talked about. And how do you do that? I've seen some organizations try to pair the PQ journey with an existing cybersecurity initiative. I've got a Zero Trust initiative going in my organization. Zero Trust calls for encrypt everything. You can't do that without doing it state of the art. PQ is state of the art. You shouldn't be putting new capability to protect data in your organization in place without thinking about post-quantum. So some organizations have been successful using that road, sort of connecting to an existing strategy. But I think sort of the end of my presentation, I'm trying to suggest other different strategies. I think we need to be able to demonstrate as security professionals the value to an organization to tackle this problem. And some of those value drivers that I talked about, resilience, compliance, efficiency, cost reduction, innovation, those are hopefully some of the attributes that we can start talking more about as a community, and I think that's going to help executive teams and boards start to think about, okay, I've got to start working on this. And I derive business benefit by doing it. Well, again, thank you all for joining. Enjoy the rest of your conference.